We start in on a new video here. We're in the middle of the story of the vector space model of information retrieval. And now I want to return to a question that we sort of glossed over last time. And I want to talk about what is a good definition of the inverse document frequency. Now you may recall we actually gave two definitions of it. We have one that we used earlier in this video, or the last video, and then we had one that we used last evening. And in one case we said that if we have some W sub I, we said that N of W sub I was equal to the number of documents containing the word we had these two definitions. We said that the inverse document frequency of Wi is equal to, in the last video, we said it was log base 2 of n over n of W sub I. Remember, the n, this is the total number of documents. Total number of docs. But then last evening we said consider an IDF that's equal to this one right here. But then to this quantity here, we add 1. And of course we said, remember, if a word appears in all of the documents, then this quantity over here would be 1, and the natural, or not natural log base 2 of 1 would be 0. That by adding 1 to it, then we're ensuring that the whole thing is a positive number. It's never 0. So the question is either one of these preferable to the other one? And I want to make an argument now that this one over here is slightly better. So what I want to do is again, I want to suppose that we have the same documents that we had here from the last video. And now what I want to do is I want to make a query. And I want to consider two different queries. Okay? And I'm going to have query 1. So query 1, I am going to be querying on cat, dog. And for query 2, my query is going to be cat, dog, dog. So remember, what I have to do is I have to come up with a document query for each one of these. And remember the way that we do it. And what we have to do is we have to look at the normalized term frequency. So you may recall when we did the normalized term frequency, this is using the first formula over here. We've already calculated that. And remember, the normalized term frequency of cat was 0, of dog was 1, and of mouse was 2. So what it's going to be over here is it's going to be 0 times something, and then it's going to be 1 times something, and then it's going to be 2 times something, and it's going to be the normal. Then what we have to do is we have to look at the normalized term frequency here. Well, the thing is over here, this appears once and this appears once, so the word that appears the most frequently is 1. So we divide the term frequency by 1, and we would get a 1 times this, and we would get a 1 times that, and over here we would get 0 because mouse didn't appear anywhere. Now likewise, using this first formula over here, okay, we would come over here And again, normalized term frequency, or not, the inverse document frequency, the inverse document frequency, the inverse document frequency. And now what happens over here is again, we have to normalize term frequencies. Well, now we notice that dog appears twice and cat appears once. So we have to divide those term frequencies by 2. So this would be times 1/2, 1 divided by 2. This would be now become a 1, and this would now become a 0. So we notice that this vector over here is just 0, 1, 0. And we note that this vector over here is 0, 1, 0. And in fact, we notice that what's going on over here is that notice that these two queries give us the same exact vector, okay, for these two different queries. Now what I want to do is I want to consider the case where I use this second formula, which would be this formula over here, which means I'm going to add 1 to all of the inverse document frequencies. So instead of this being a 0, this would be a 1. And instead of this being a 1, it would be a 2. And instead of this being a 2, it would be a 3. And the same thing would happen over here, and over here. And now when I come down here, over here for query 1, I get that my DQ is equal to, well, this would now be a 1. So that's 1 times 1. This would now become a 2, so that's 2 times 1. And I'd come over here, and this would now be 3 times 0. And I come over here, and the DQ over here is now equal to, it would be 1 times 1/2. And over here, it'd be 2 times 1 is 2. And over here, it'd be 3 times 0 is 0. And now notice these are different. And over here, they're the same. Okay? Okay? Cat dog and cat dog dog will give me the same vectors when I use an inverse document frequency like this one right here. But I will get different ones when I use my second formulation for the inverse document frequency. So that says to me that I think that the second formula we have, where we add 1 to whatever we calculated, is better. And this shows it right here. So that was just a very quick video here. I hope you get that. And we have one more to go.